Hi everyone, my name is Sam. I previously showed a video on how I machined this hub with some time-lapse shots. I had a few people ask me when I put this up, oh, can you show how we did some of the small things like drill the spoke holes and my disc brake flange right here. So I needed to make a new hub once again, and it's to replace this one here, which is for another project altogether. I also made this one, but I've had a bit of a change of design and I need to make something new again. So I'm going to go through the steps that I go through, which is quite a lot to make a new hub, and it's going to be more complex than these two. It's going to have a threaded end on it for this ACS 14 tooth freewheel. This has got a 30mm diameter instead of the usual 1 3/8 to fit the most commonly known as the flip-flop hubs or dual-sided hub. They have it's a smaller diameter and it suits my needs pretty well. But I'm also going to have a 12mm axle and also a disc brake flange on the far side. Just got my crappy drawing here, and it shows like the disc brake flange on here. We've got a very wide set apart spoke flanges and the threaded end on the far side. I'm going to have two very small double bearings on that end, and just a normal 6001 at this end with a very thin wall 12mm axle. So what I'm going to use for this is this big chunk of here it is, 6061 aluminium, obviously, 60mm diameter, and turning around, I got it written down. Yes, there we go. 913 grams. For the Imperial guys, that's very close to 2 pounds. I'm hoping to get this down to about 120 to 150 grams. Any more I'll be a bit disappointed. So let's go turn this into swarf. Right, I'm going to start by parting the face and putting a 20mm hole all the way through. I'll be using this high-speed steel cutter. I normally use the tungsten sort of tips for all my harder metals, but for this stuff I ground my own cutter. It's normally what I use, unless I've got a special reason not to. Okay, to set up my quick change tool post, and yeah, I'll face it, then spot it, and then wind the 20mm straight through it. So let's get started. I keep a chuck with a center drill locked in at all times. I figure the price of a chuck, it's just not worth the time to keep on changing them in and out. So I do that with both my lathes, and I have a separate chuck again for all the drill bits that I change. Okay, pop this out, and now I'm going to go for the Morse taper 20mm drill bit. I'm not going to do a pilot drill, don't really see the point. Okay, do that right up. Try that. Next up, I'm going to start the first turning of the outside diameter. I have already touched this face here and zeroed my digital readout. Now if this is more accurate, I would actually skim a tiny piece off and zero it, because just touching it obviously isn't as accurate, but for this it doesn't really matter. Now I'm going to reduce diameter to 1mm before where the spoke flange is going to be about here, which is 32mm in, so I'll take it to 31, and at the same time I shall take it down at 2mm lip, and that is to mount the disc brake on. So what I'll do is I want to skim the outside, measure it, and then set that as the X dimension on my lathe, and I'll check it later on, but I'll probably just do that twice, and I'll reduce it down to the outside diameter of where the mounting for the disc is going to be and the center of the disc, and then later on I'll take the groove out next to the flange. I've changed the tool now. I've taken my whole quick change tool post off and fitted this. I keep it just for my parting tool and milling tool, and I'm going to cut the recess in between the spoke flange and the mounting for the disc brake. So there'll be a slot cut in there that I'm going to do now, and I'm going to do it by diving in the parting tool until I reach the required depth. I've done a shallow cut for which I put my vernier caliper on and measured it, but so I need to wind that in, and I've already set it also off the end, allowing for the 2.2mm width of the cut itself. I know that it's a 2mm blade, but in my own experience it does cut exactly 2.2. I'm guessing it's a bit off the sides that it catches. So I'll get started on that right now. Right, the slot is now cut for the end there, and I'm going to put a taper on this spoke flange, but not at this stage. I'll be probably doing it closer to the end as final finishing. Instead, what I'm going to do is I have this drill bit here which is 26mm, and I'm going to drive that fairly deep into the hub, which is 115 I think. The reason I'm doing this is because I'll have the larger of the two bearings on this side, and I'll have a staggered through hole to maximise the amount of weight saving I'll have. And because it'll start for the big bearing and then hole through this bit's just a little bit smaller, and then go down smaller again for the other bearing with a step in the middle to stop it pushing in. So I need to start this off, and unfortunately my scale on the tailstock only goes so far, so I will have to actually check it by hand, which means carefully sliding a vernier in the side a bit at a time with trial and error. I'll get started. I've finished boring out the hole. Now what I'm going to do, that took it out to 26 with a drill bit, but I want to take it out to 27, which I don't actually have a drill bit for. So I'm going to use this boring bar. Now I just thought I'd show this. This is got a special tip. It's chromed, I assume, and it's still tungsten carbide, but it's actually a special grade purely for soft non-ferrous materials. The polish finish is so it doesn't stick and bind up, and I bought this in the American tool supplier Shars, because the tool companies in Australia suck pretty bad and they're quite expensive. So because I didn't show it before, my quick change chuck, it slid straight in, and I use blocking spanner and do that straight up. It's already been set to the right height. I've just finished boring at the inside of my large boring bar. I've swapped to my smaller boring bar so I can do a bearing recess. As mentioned previously, I'm using just a basic 6001 double shield, so it's a 2RS, and it's going to be situated very close to spoke flange for good stress distribution. Now I've done a basic cut with my small boring bar here, and I've got my inside micrometer. This is a really nice bit of equipment. It's made by Meditoyo, and it measures from 5 to 30 mil. So all I do is, I know it's no good view from the camera from there, but I sit it inside, wiggle it, take note, and have a look. And it's actually really accurate compared to the crap I was using before. I've finished cutting the recess now. Because there's a bit of trial and error involved in cutting these due to the very close tolerances they need to have, I do two things to try and improve my chances of, well, not stuffing up fully. One of them is that when I'm getting close, I like to just cut the recess in the outside 5 mil or so before the critical part of the recess, and then I test my bearing in the non-critical section before I continue and plunge all the way to where it needs to go. Another thing is to do a test fit is I use a bolt, in this case a countersunk, could be whatever, and put the bearing through it, and this way when you do a test fit you can stick it in and you can then yank it back out, and also have this cutter well and truly away, because you know it really hurts to hit it with your hand. So now that's done, I'm going to skim the outside of this, which I should have done before really, and the reason why is when I reverse this I'll have a nice even known surface that's relative to this that I'm going to mount it with. Otherwise I'll have to put a dial indicator specifically on the inside instead of the outside, which is just a little bit more mucky around, but it's a professional thing to do regardless. With the bearing recess now done, I've changed the chuck to a 4-jaw. The reason why is for greater accuracy. Now the 3-jaw, to do the first cut, it doesn't matter what chuck you really use. That's why I used it, because you have nothing to compare to, no reference point, so whatever you cut you use that. But now that I've got my bearing recess on this side, just sticking inside the chuck now, I need to cut another bearing recess and make everything match that side. Now if I just put it in a 3-jaw, it will not be as accurate. No 3-jaw is exactly right, even brand new ones. If you want true accuracy, a 4-jaw is the only way to go. So you put it in here, you dial it up using a dial indicator, which I'll do in a moment, and go from there after I got it like dead central. A few points of note: there's a really good guide on YouTube called Easy 4-jaw Chuck Centering. Type that in and it shows a video on how to make it surprisingly easy and quick to do. But a trick that I do is, firstly I take it out of gear and I have triangles on opposing sides and arrows, so I don't get them mixed up. And also get 2 of these, so you can always adjust, you can feel it and gently move it back and forth without moving from one side to the other, which can cause issues that are hard to explain. But go from there. I'm going to set up the dial indicator now and center that to within approximately 0.02 of a millimeter. Just showing quickly how I've got my dial indicator set up. It's a little awkward, but I just couldn't be bothered moving it. Got the face, got the probe on the side on my nice machine section on the outside, which is really handy. And then I just grab these and shift it according to that, same as that guide I mentioned earlier. Alright, time to machine the other side. With the other side machined, I've taken it back to this face here, which will be the new spoke flange, and I'll cut a taper on this shortly. And I've left a shoulder here. This is so the sprocket, the freewheel, can widen up against this. Because if there was a thread that just ended, the freewheel would just jam up when it reaches the end of the thread because it would taper off. However, with a shoulder on the end, you can wind up against it and be unwound without a problem every time. And I've done this cut here and here to both of the nominal thread depth. Being a 30 by 1 millimeter thread, it'll have a 28.77 depth. So in other words, this here the very tips of the thread cut shall touch it, and this space allows the thread room to, when during the cutting process, allows like an area run out room for it to stop, so it doesn't end up being tapered. And this area here is so it gives me clearance when I run like a live pipe center or some sort of live center. I have room for the thread cutting tool to fit in here and clear the actual pipe center. And having this little bit of overhang is not going to bother me really, because I'll have it pretty close to the forks. So I also now, as I mentioned earlier, I'm going to have a double bearing in this end. It's a pretty, because I'm going to have a 12mm axle and I don't have much of a diameter here to work with, I'm going to have a pretty small profile bearing. These are more sensitive, so I've got to be really careful, and to allow for the extra load, you know, smaller means can't handle the force as much, premature wear and so on. So I'll be running a double bearing here. I'm going to get started now. The bearing recess is now cut. It worked out quite well. I've only got one in there right now, and the bolt, as I said before, to yank it back out. I have also put a bit of a taper on here. From here I'm going to, that is so. It's quite a tight fit, which is good. I also forgot to mention before, but I like to put a countersink type insert in the end, because you never know when you might need to put it on a live center to have a correction or something. Quite often you machine things off and there's no way to properly grab it in a lathe anymore. To do that, I use this tool here. It's called by various different names, countersinking bit, yeah, or something like that. It's actually fairly expensive. However, put a bit over, you can see it better. But it's well worth the money. It leaves a very smooth, nice finish that normal countersinking bits on aluminium, they leave like a jagged, rough finish. But this is fantastic. I think it cost me a good $60, but it does a great job. I've already started to do this turning right here, which is for the metal removal between the two spoke flanges on either side here. I'm using this custom ground equivalent of a parting tool, I guess. It's very wide and pretty much nothing beats in terms of pure metal removal. I've given it quite a high set of relief angles, so I can really bite into this soft material and just make the metal fly off. I'm going to make my whole lathe covered in these little pigtail type bits of swarf. So I'll give you a demonstration of how it goes. With the bulk of the center now removed, I've left these corners here. I've just approximately put some steps in it, because what I want to do next is I have this home ground radius cutter that I want to bring into the corners and have hopefully a really gentle radius for good stretch distribution, and it should look quite nice too. So I'll wind this in and see what I can do with it. The middle's been carved out. I finished with a radius cutter and the shape's good, finish isn't. That's pretty normal with a radius cutter because I don't have a high relief angle on it, and it does try and cut a large amount of metal all at once, because it does like at least 3/4 of the end of the radius when I stick it right into the corner. So because of that I get a little bit of chatter. However, a bit of sandpaper and it's easily fixed. So that's what I'll do now. I'll sand it, get rid of all the marks, including this nasty band I've got in the middle. I don't know if you can see it from there. And then I am going to put a bit of polishing compound on it, seeing it's a good opportunity. The middle has now been sanded. I've taken off any chatter marks, and I've also gone over it with one of these scour cloths. Panel beaters use these to prepare the paint, but they're actually really good for polishing aluminium. Now I'm going to use some good old Autosol polishing compound, and polishing a lathe is actually quite easy. Obviously you just have to watch out that you don't get your fingers too close to the chuck, because that kind of hurts. Now put a small amount on the rag. that's it. I'm not looking after an excessively good finish, but I'll give it one more coat and then I'll take it out and move on to the next step. The hub's been removed from the lathe. I've now put it into my rotating table. I modified this a little while ago. This is my original lathe chuck, probably the one that featured in the last video, and I drilled through from the other side and then canterboard to bolt it to my rotating table. I've preset this to be dead center through the center of the table to the chuck. So what I'm doing here, I've got my digital edge finder. This, when it touches, it well, does that. When it touches, I know it's to the edge. I zero it. I know the ball is exactly 10 millimeters, so if I move to that side, zero it, move to the other, and then divide it by half, move to that point, and zero it, I know it's the dead center. So what I'm going to do is I'm going to zero this, and then I'm going to use a center drill to do my spoke holes, and also I plan on doing a ring of lightning holes around the inside edge here in 6mm, but I'll see how that works out. I want to drill a set of spoke holes with a 54mm PCD, so I've offset the Y dimension 27mm. So what I'll do is I'll start this. Just got a normal slotting drill. And then because I want 18 holes on this side being a 36 spoke, I'm going to move it 20 degrees. And I'll lock up the table every time to stop it moving. Now that I've finished spotting with this center drill here, I'm ready to drill the holes for the spokes themselves. The reason why I had to use this is because as shown before, I machined these spoke flanges on like a taper. If I tried to drill this straight away, it would wander and either snap the drill bit or drill a very wonky hole. So I've already done the first hole, so moving it back to a 0-degree position, lock it up. I've now finished drilling all the spoke holes, and while I had the 2.5mm drill bit, I used it to pilot drill these ring of holes I'm going to have around the outside, which are to lighten the flange itself and also for decorative reasons. I didn't need to use a spot drill because it's a flat face, and unlike with a pedestal drill, a milling machine holds everything steady, so you don't usually need to spot things all the time. And the higher the speed you run, the better it is in that regard. Now I've already drilled the first hole. I've already got written down what 1/14 of 360 is, so I know where every single hole is. So moving along, the next hole's at 0 degrees. Run that down. Also of note, dividing tables, and you should never really do that. These use, this particular one uses degrees. Some people use dividing tables instead that use fractions, which I just think is just does your head in. But the only problem with these is they don't use decimals after the round degrees. They go their round number, minutes, and then seconds. For example, this hole I've just lined up is 25 degrees and 43 minutes, which I already got my little chart that I worked out. Pretty simple to work out. I got 360, I want 14 holes, so I divided by 14, that's 25 point something degrees, and the decimal point I times it by 60 to work out the number of minutes I need, and then I add that every single time for all 14 holes. I'm going to drill the rest of these now, and then I'll see if I can do something about the bottom holes. Okay, top holes are done, and I've just done the bottom holes as well. I don't really like how it's turned out. It could be more accurate, but still looks nice. I used a few different methods, but I finalised it with this 6mm drill bit all the way through. It is rough. Ideally I would have had a 1/4 inch long center drill, but I didn't. And the one I had that was long enough, which kept on warping too much. So I had to use various tricks to try and get it right. I don't think a person would pick it, but they are a fraction off. Now what I'm going to do is take it out and put it in the lathe and clean up a bit, and then I'm going to do the disc brake flanges. I've drilled the holes for the disc brake mount, and what I'm doing here is I'm tapping the holes. I have a tapping head, however it only goes down to M6 and disc brake mount's being M5. Well, I've got to do it this way. What I've done is I've directly grabbed the tap with one of my collets, and I'm just being very careful, being such a fine thread. Out on low speed. Stop at the middle. Reverse a little bit. And keep going down. But don't take it all the way down. I'm going to run a bottom tap in it later on. I'll do that by hand. So all I want is to guarantee that that each thread is going to be straight, because I only need to start it for the thread to be straight every time. If I do it by hand, once it starts crooked, it stays crooked. The hub is now done. I skipped a step of showing how I cut the thread on this because I was kind of feeling disinterested, and also there's plenty of videos on YouTube already on how to cut threads. But it's a 30x1 thread at this end, and I've gone liberty of wanting on this ACS freewheel sprocket. My bearings are in both ends. Looks really nice. Got it flush at this end, and I've made a bit of a stuff up with some spoke holes. They're not totally right in one end due to some bad center drills, but otherwise it's pretty good. I'm quite happy with how it turned out. The final weight there is 115 grams, which is seriously light, and yeah, it should work really well. I'm waiting on some spokes, and when I get them in, and hopefully if they're right, I'll be lacing it up to my trials tyre and tube. Well, thanks for watching everyone.